Hello, geometry geniuses. We're going to talk about 9.6 with dilations. We're skipping a few sections because with this chapter, I want to get to the meat and bones of when we translate images or reflect them or have a dilation in this case. So the goal here is that we're going to understand dilation images of figures. If you have ever been to the eye doctor before, you might have had your pupils dilated. What that does is it makes your pupil of your eye wider so that the eye doctor can see more of what's going on in your eye. This is usually done with eye drops, but you might also have seen this maybe in elementary school with science, how in certain lights your pupils get dilated a certain fraction of the normal amount, or it gets exposed to more depending on if you're in a bright light. So it depends on the type of light. And with geometry, we do the same thing where we have the dilation. So it's either making a shape larger or smaller in reference to the original pre-image. So we say that we have a dilation with center of dilation C and scale factor of n, where n has to be greater than 0. This notation here says that we're working with a dilation that has the scale factor of n, whatever the number may be, and this is based around the center of C. We see that the image of C is itself, that is C prime equals C. So the center stays the same. For any other point R prime is on CR for the ray, and CR prime is n times CR. This can be a little complicated, but what's going on here is that we had the pre-image of PQR with center of C, and there was some scale factor that made this, let's say, twice as far away from the point C, and also expanded the length of PR, RQ, and QP, so that ideally they were also, let's say, like this is twice as big. P prime to Q prime is twice as big as P to Q. Same with all of the other segments. So that's a quick synopsis. We'll see this example here. Back with Mona, we are working with this pre-image where the bottom left is 3, 0, 6, 0. So let's say that we were going to dilate this. If we had a factor of just 1, that means it would just stay the same. Well, let's see what happens if we make this 2. Well, now that this is dilated by 2, again, with the center being the origin, 0, 0, we see that the bottom left point is now 6 units away from the center of where we were dilating this. We can also say that the bottom right is now twice as far away. Originally it was 6 units, now the bottom right is 12 units away. If we look at the height from 3, 0 to what appears to be 4.2 for the y-coordinate, it looks as if this is about twice as long. So notice that the distance from that center has been doubled. The height has been doubled. The base has also been doubled. So notice the base was originally 3 units from 3 to 6, and now from 6 to 12, that's 6 units, which is twice as much. Notice that if we were going to take this less than 1, what do you think would happen if our scale factor was less than 1? Well, let's check it out. It would be dilating, so this would go smaller. Let's make it half as much. Zoom in on this. So again, the pre-image is this larger image on the right with this scale factor of 0.5. Notice that the bottom left is now 1.5 units away from the origin, the center. The bottom right for the prime image is now 3 units away, whereas before it was 6. We can also assume that the height is half of what it was. Same with the base is half as much of what it was. This looks as if it's about 3, and now it's 1.5. I hope this was helpful. If you have any questions, bring them to class. Thanks for watching.